Modified Gauss integral 7. This is the 7th video on my series of modified Gauss integral, where the modified Gauss integral refers to this form: integral from 0 to infinity of e to the power minus x square f of x dx. Yeah. Over there it is r of ax for this case. There are also other plenty of videos on my channel in the playlist of modified Gauss integral. Do search that if you want similar other videos. Now let's go with this one. We know that the definition of OR function, basically OR of any input ax will just be integral from 0 to ax, yeah, and then I'm sorry, and then e to the power minus t squared dt. Yeah. Now you can also substitute, let's say y equals to t by ax. If you want to change the limits of integral to numbers 0 to 1, and then this will be e to the power minus a square x square y square ax dy. Yeah, you can do this, and we will use the second interpretation of OR function for this one. Integral from 0 to infinity e to the power minus x square, integral from 0 to 1 e to the power minus a square x square y square ax dy dx. Yeah. Now let's take this inside the integral and interchange both the integrals. Yeah, and most of the time interchanging integrals will make things simpler. And e to the power minus x square common, 1 plus a square y square. Yeah, and then this is ax dx and dy. Fine. Now okay, now fine. What we can do is take a outside and by 2, integral from 0 to 1, integral from 0 to infinity, yeah, and e to the power minus x square 1 plus a square y square, and now this is 2x dx dy. The reason I do this is basically if x square be g, 2x dx is just dg. So we just have e to the power g times some constants, and that's easily integrable, you know. A by 2 integral from 0 to 1, this is just e to the power minus x square 1 plus a square y square by this constant. And I forgot something. I just remember that the OR function is not just this integral. OR function is actually this integral. I'm sorry for forgetting this thing, but this is actually important thing. OR function is this integral times 2 by root pi. Actually, I forgot that. I'm sorry for that. I just remember. So this is this times 2 by root pi, and I was messing up the whole calculation due to that. Times 2 by root pi times 2 by root pi times 2 by root pi times 2 by root pi. I'm sorry for messing this up. Okay, now fine. This is root pi, and 2 cancels out. Yeah, and by minus of 1 plus a square y square dy. Fine. Now this is a by root pi. Yeah. And okay, so this should be evaluated from 0 to infinity. Yeah, I forgot to write that. Now this integral from 0 to 1. At infinity this is 0, and then minus minus plus. At 0 this is the upper part is 1, so 1 by 1 plus a square y square dy. Now this is just a by root pi, and then tan inverse ay, and since the coefficient of y is a, we also write 1 by a over here. This goes from 0 to 1. A cancels out, and we get 1 by root pi tan inverse a minus tan inverse 0, tan inverse a, and that's the answer. Tan inverse a by root pi. Yeah, that's the answer. And to talk about the flow of the problem, we first used the definition of OR function with limits being the numbers, and interchange the integrals, and use the integration of the inside integral, and then also integral. We got the answer. This wasn't too tough, like just you had to write in terms of integral and interchange it, and you would get the answer. That was it. Hope you enjoyed the video. Thanks for watching and look forward to seeing in the upcoming videos too.